Chapter 1, Matter in our Surroundings. In this chapter, we are going to study about matter. Let us start the chapter with introduction. We see a large variety of things with different shapes, size, and textures. We all are surrounded by many things. The things which are circular in shape, square in shape, rectangle in shapes, and many other shapes. The things which are very small in size, very big in size, and the things which are smooth, rough, and having different type of textures. Everything in this universe is made up of material, which scientists have named matter. So, everything which we are surrounded, that all the things are matter. If you think of anything like water, milk, books, pen, pencil, all the things are matter. The air we breathe, the food we eat, stones, clouds, stars, plants and animals, even a small drop of water or a particle of sand, each thing is matter. So you can see here that all the things are considered as a matter. Let us see the definition of matter. Anything that occupies space and has mass is called as matter. Suppose you take example of book. Now if you keep a book inside your bag, it will occupy some space in your bag, and when you lift the bag you will feel some mass or some weight in it, and therefore the thing which occupies space and it has mass, that things are called as matter. Every Indian philosopher classified matter in the form of 5 basic elements, and that are called as Panch Tattva. Panch Tattva includes air, earth, fire, sky, and water. Now these 5 things are called as Panch Tattva, and these all Panch Tattvas are nothing but matter. You should remember what are the Panch Tattva. Now let us understand physical nature of matter with activity. Now this is the first physical nature of the matter. This is the first physical, that is matter is made up of particles. First point. This is the setup of the activity. What we have to do, let us see now. Take a 100 ml beaker and mark level of water. So here what we are going to do, we will take this type of beaker and mark a level of water after filling water in it. After that, dissolve some salt or sugar in that beaker and observe any change in water level. Now this, you can see here, we have filled the beaker with the water. After that we are going to put salt and sugar in the beaker and stir it. After stirring, you have to observe any change in the water level. Now what will happen, you will not see any change. The water level remains as it is. Now, these few questions will arise. And what do you think has happened to the salt? Where does it disappear? And does the level of water change? So these three questions will give you the answer. Here there is a no change in water level, and the reason is when we dissolve water in salt, the particle of salt gets into the space between particles of water. This thing shows us that the salt are small particles, and even water is also a matter which is made up of small particles. The water have particles which have space between them, and between that space there is a solid particles of salt will sit in between, and therefore you will not find any change in the water level. And where does it disappear? It has not disappeared anywhere, but it has set in between the space of the particles of water. And this activity shows us that matter is made up of small particles. The next activity which will help to give you the another physical nature of matter, how small these particles of matter are. This is the thing which you have to do in this activity. Let us see the steps to follow. Take 2 to 3 crystals of potassium permanganate and dissolve them in 100 ml of water. You have to take one beaker like this, take 100 ml of water and add potassium permanganate in the beaker. After adding potassium permanganate, you have to stir it properly. Once you stir it, the color of the water changes from blue to pink. Then after, take out approximately 10 ml of this solution and put it into 90 ml of clear water. Now you have to take a new beaker, that is this one, another beaker. Take 10 ml from this and fill it with this water in the test tube, only 10 ml. And this 10 ml you have to put it inside new beaker of water. Then stir it properly. Again take 10 ml of the water from the third, that is nothing but from this beaker, and then put it inside the fourth beaker. Again do the same thing and fill it with the test tube and put it inside the fourth beaker. Now repeating this for 4 to 5 times, you will find that the last beaker which we have got, it will still have some pinkish color in it. Okay, take out 10 ml of this solution and put it in the another 90 ml of a clear water, that I'll already explain what you have to do. Keep diluting the solution like this 5 to 8 times and observe, is the water still colored? So this is the thing which you have to do in this activity. Now what does this activity shows us? This activity tells us that the beaker, which is the last one, when you observe its color, it will still have pink color, but when you observe the first beaker, it will be dark pink in color, whereas the last one will have light pink color. If you keep on repeating this, the particles will dissolve in the water and it will get smaller and smaller in size. See here, estimating this activity, what we are going to get from this activity. Estimating how small are the particles of matter. With every dilution, though the color becomes light, it is still visible. Now when you dissolve potassium permanganate, the particles of potassium permanganate keeps on dividing into the smaller one, and it will keep on giving color to the fresh water. Okay, so you can imagine the small size of particle. Even if you are taking 10 ml from the beaker, imagine very small amount, and that is also have capacity to color the new water. Now when you take this test tube, it this is a little lightish in color, and this also has capacity to color the another beaker. So overall conclusion of this activity is that the matter has a particles which are very small. What you have observed in this activity, we'll see now. This experiment shows that just a few crystals of potassium permanganate can color a large volume of water, that is about 100 liter. So we conclude that there must be millions of tiny particles in just one crystal of potassium permanganate, which keeps on dividing themselves into smaller and smaller particles. So even a small crystal of potassium permanganate contains millions of small particles. From physical nature of particle, you can understand that matter is made up of tiny particles that we have already seen in first activity, and particles of matter are very small. They are small beyond our imagination. So when a crystal of a potassium permanganate can color up to 8 to 9 beakers, you can imagine the size of the particles. They will be very small, we cannot see with our naked eyes. Particles of matter have space between them. Now this is the characteristics of the particle of matter. Actually there are three characteristics. This is the first one. When we make tea, coffee or lemonade, it is limbu pani, particles of one type of matter get into the space between particles of another. So what happens when you make tea? And tea required, we know that, sugar, tea powder, or you can say tea leaves, and milk. When you add tea leaves and sugar to the milk, what will happen? Sugar will sit between the space of the milk particles. Or else when you make lemonade, you have to add lemon juice and salt or sugar to the water. Now in this case, liquid is also having a small space between the particles. So lemon juice and water both are liquid, so therefore they both can sit between the particle space, as well as salt and sugar will also sit between the space of the particle of water. This shows that enough space between particles of matter, that there will be enough space between the particles of matter so that another matter, the particles of another matter can sit in between the particles. The second characteristic, that is particle of matter are continuously moving. Now this we will see with the help of few activities. The first activity is using incense stick. If you see incense stick, the incense stick doesn't produce any smoke when it is not light, but when you once light it, what will happen, it will produce smoke, and you can see that the smoke is continuously moving. The smoke is nothing but the particles of gases. So first activity which shows that particles are continuously moving. The next activity, that is nothing but by using honey and ink and in water. Add honey and ink in water. You have to observe the activity properly. Here you are adding honey and here you are adding ink. Now after 1 hour you have to observe it. You cannot see much change in this, but here when you see, it has completely changed the color of the water. Now when you have put the ink in this first case, what happened, the ink directly settled at the bottom, and after an hour if you see, it has spread through the whole water. Now what does this activity show? It says us that the particles are continuously moving and they will mix throughout the water. The third activity is of copper sulfate in water. Take a copper sulfate crystal, this is copper sulfate crystal, and you add it in water. You can see that the copper sulfate, when you are adding the crystal in it, what is happening, it is coloring the water, it dissolves in water. It will take little time to give color to the water, and this activity again shows that the particles of matter are continuously moving. Particles of matter are continuously moving, that is, they possess kinetic energy. Kinetic energy is the energy possessed by any object when they are moving. So particles are also moving, we can say that they has kinetic energy, and kinetic energy depends on temperature. When you increase temperature, kinetic energy will also increase. Kinetic energy increases means the speed of moving of particle also increase. As the temperature rises, particles move faster. So we can say that with increase in temperature, the kinetic energy of the particles also increase. Okay, just now I explained, when you increase temperature, its kinetic energy increase. Its kinetic energy increase, so the speed of the particle will also increase. Now in the above three activities, we observe that particles of matter intermix on their own with each other. They do not They do so by getting into the space between the particles. This we have already seen. When we put ink in the water, slowly it will mix with the water. It takes some time, and this happens because they have space between them. Now the definition, very important point, listen it properly. Intermixing of particle of two different type of matter on their own is known as diffusion. So diffusion is nothing but intermixing. Whenever the word comes diffusion, you have to remember that it is intermixing. In this chapter, in this later chapter, this word will be frequently used. Okay, diffusion meaning intermixing of particles, and it will be by their own. We are not doing anything to mix them. And on heating, diffusion becomes faster. Now what is the reason behind this? When you heat any matter, the space between the particles increase, and therefore any person, we are talking here about particles, any particle can easily sit between the space of the particle. Okay, third activity, that is particle of matter attracts each other. This is the third characteristic and the final one. Let us understand the particle of matter attract each other with the activity. Take an iron nail, a piece of chalk, and a rubber band. Now this is the first activity. What you have to do in this first activity? Take these three things and hit it with the hammer. When you will hit with the hammer, you can observe that iron nail has little bent, but it has not broken. When you hit the piece of chalk with a hammer, it will break, and when you stretch the rubber band, it will get stretched, and after removing the force, it will again come back to its original position. Now in these three cases, you can say that the particles are attracting each other. In iron nail, they are having strong force of attraction. The particles are holding each other with a strong force, and therefore they are not allowing iron nail to break. Whereas piece of chalk have little lesser force, and therefore they are breaking. The chalks can easily break by application of force because particles have less force between each other. And rubber band, they have the maximum force, you can say. When you apply the force, they will get change in its shape, they will stretch, and after leaving they will again come back to the original position. The second activity, open a water tap. Try breaking the stream of water with your finger. Now, in this activity, you have to just open the water tap and put a finger between the flow of the water. What will happen? Water will get splitted into the two streams. Now, here also you can say that the particles have space between them, they are moving, and the last one is they have force of attraction. They will never get separated into different particles. The above activity suggests that particles of matter have force acting between them, and there will be the force between the particles of matter. They will never get, if the force decrease, what will happen? They will get broken down or they get separated. This force keeps the particle together. The strength of this force of attraction varies from one kind of matter to the another. Now, there are different types of matter. In different matter, the force of attraction between the particles will also be different. Suppose in a, you can say that in a hard thing like a computer, the force of attraction between the particles will be very much stronger. In water it will be little less stronger, and in the gas it will be very less. Thank you for now. Understand this characteristics of the particle and physical nature of the particle properly. In the next video we are going to study about states of matter.